All right, today we're going to tackle one of the biggest, most powerful rules in the entire universe. Seriously, it's this hidden law that explains why your coffee gets cold, why you can't unscramble an egg, and even why time itself seems to be a one-way street. So, let's just dive right in. Have you ever noticed that some things in the universe they just happen? A glass shatters, an ice cube melts. But the reverse? A shattered glass putting itself back together? That feels completely impossible. It's almost like there's some kind of cosmic traffic law, and everything is flowing down a one-way street.
Let's take this simple question. You can crack an egg, whisk it up, cook it. That's a process that happens, no problem. But have you ever seen a plate of scrambled eggs spontaneously reform into a perfect whole egg, shell and all? Of course not. It sounds absurd just thinking about it because it just never, ever happens.
Or what about the classic messy room? We've all been there. It can go from tidy to total chaos with almost no effort at all. But have you ever left a messy room for a while and come back to find it has magically tidied itself up? No way. The natural tendency is always toward mess, not order.
And here's one that's happening literally all around us, all the time. A hot cup of coffee will always, and I mean always, lose its heat to the cooler room around it. But you will never ever see a cold cup of coffee start to get hotter all by itself just by pulling heat out of the cool air. It's just another one of the universe's super strict one-way rules.
So you see the pattern here, right? The unscrambled egg, the messy room, the cooling coffee, they're all following the exact same deep physical principle. There is a single, inescapable law of nature that's calling the shots and dictating this direction of change.
And that governing principle? Well, it has a name. It's known as the second law of thermodynamics. You can kind of think of it as the universe's official rulebook for how energy behaves and why everything naturally moves from a state of order to a state of disorder.
Now, back in the 19th century, scientists figured this out and described it in two key ways. First, you have the Kelvin-Planck statement, which basically says you can't build a perfectly efficient engine. Some energy is always going to be lost as waste heat. And then there's the Clausius statement, which is what we saw with our coffee cup. Heat always flows from hot to cold on its own. They might sound a little different, but they're really just two sides of the exact same coin.
But to really get to the heart of the second law, we've got to talk about a concept called entropy. You can think of it as the secret ingredient in all of this. Or maybe more accurately, it's the universe's official way of measuring messiness.
So what is it exactly? Well, entropy, which scientists usually represent with the letter S, is a precise measurement of the amount of randomness or disorder in any given system. So the more disordered something is, the more spread out its energy is, the higher its entropy.
This card deck analogy is the perfect way to get your head around it. Imagine a brand new deck of cards, all ordered by suit and number. That's a state of very low entropy. Why? Because there's only one single way for it to be perfectly ordered. Okay, now shuffle it. It's now in a random high entropy state. And here is the absolute key. There are trillions upon trillions of ways for that deck to be messy, but still only one single way for it to be perfect. The universe just plays the odds, and it is overwhelmingly more probable for things to be in one of those countless messy states.
And this all leads us to the most powerful, most absolute statement of the second law. For any process that just happens on its own, anything, from an ice cube melting in your glass to a star exploding across the galaxy, the total amount of entropy, or disorder, in the entire universe goes up. It never, ever goes down. That's the rule. Okay, so if the universe is on this unstoppable, one-way journey toward more and more and more disorder, what does that actually mean for us, for our everyday experience? Well, it fundamentally explains one of the deepest mysteries of our existence, the forward flow of time.
This is such a profound idea. The reason we experience time as a one-way arrow, where we can remember the past but we can't remember the future, is because of entropy's relentless march forward. The past is just a state of lower entropy, right? It's the ordered deck, the whole egg. The future is a state of higher entropy, the shuffled deck, the scrambled egg. The direction of time really is nothing more than the universe unfolding into its most probable, most disordered state.
And this leaves us with a huge final question to chew on. If the universe's total disorder is always increasing, where is this all going? What happens when the cosmos finally reaches a state of maximum possible entropy, where everything is just uniformly random and spread out? That, right there, is the ultimate destination on the universe's one-way street.